Okay, so we're going to start talking about solving absolute value equations. So the first one we're going to look at is absolute value of x equals 8. And what I'm going to do is pull up the calculator. I'm going to go to y equals. And if I go to catalog, catalog's right there, and ABS is absolute value. So the absolute value of x. And then for y2, I'm going to enter 8 because that was the right-hand side. I'm going to graph this. And there's our absolute value, and there is our line y equals 8. Now, so what I'm going to do is use the calc menu. And I want to find where these two lines intersect. So the first curve is the absolute value of x, the second one is 8, and it wants a guess, so I need to get closer to one side than the other, or to one intercept than the other. And there we see an intersection at x equals -8 and y equals 8. So x equals -8 is a solution. And then I repeat, intersect. So the first curve is the absolute value, the second one is y equals 8. And I need to be closer to the other intersection point. So there we go, and we see x equals 8 and y equals 8. If I go to the table, go down through, and you see y1 equals 8. And the corresponding x value is -8. And then we go the other direction. And it's a ways apart, but there we go. At 8, we're also at 8. Okay, so let's go back and look at another example. So the solutions are -8 and 8. So here we have x plus 1 and absolute values equals 5. So the inside can equal 5. So x plus 1 can equal 5. Or x plus 1 can equal -5. And then when I take the absolute value, it's equal to 5. So I have two equations, two linear equations. I solve each one for x, and I get x equals 4 and x equals -6. Now I'm going to go to the calculator, and I'm going to enter the new one. So it was absolute value of x plus 1. And then the right-hand side is 5. So I hit graph. Okay. Actually, what I'm going to do is I'm going to go to table. And what I'm looking for is a 5 and y1. So this is the x value, and the x value of 4. I have a y value of y1, which is the same as y2. So x equals 4. And this is why analysis is good, so that now I know where to look. I need to be looking over here towards -6. And there we have x of -6, y1 5, and then y2 5. So I've verified my solutions from the by hand method. Okay, one more. That is the absolute value of 2x minus 3 equals 11. So this time I'm going to go straight to the calculator. And I'm going to type in 2x minus 3. I left off the x, didn't I? X minus 3. And then for my y value, it is 11. Now, when I graph, I'm not going to see the line 11 because my window is from -10 to 10. So I'm going to graph. And we don't see the upper part, the line y equals 11, because it's off the screen. Alright, so I start looking for 11. And these are getting smaller, so I'm going to keep going this way. Oh, what do you know? There's 11. X equals -4, y1 equals 11. I keep going. There's 0. Now I'm starting to increase again. And there is a y1 value of 11. And so that happens at x equals 7. So I can't remember what, so 7 and, whoops, too far. And there's my other value at -4. So my two solutions are 6 and 4. So let's solve it by hand now. 2x minus 3 could be 1. Oh, that's supposed to be 11. You're probably wondering what I was doing. So 2x minus 3 can be equal to 11, or 2x minus 3 can equal -11. So we solve each set of equations. And I get x equals 7. Oh, that's supposed to be a 3. So adding 3 to both sides, I get minus 8, and then divide both sides by 2, I get x equals -4. So I get two solutions, 7 and 4. So I would write that, well, my math lab probably gives you something that looks like this, and so you would enter -4, 7. And that is all that I have for this video.